never stopping, just to see what happened. And the results were favorable. As you see, the Wards Brook more or less stabilized at the end for those last 2 years. It's low, it's down in the 460 to 70 gallon per minute range. So it's a low water condition, but it never reached the threshold condition that was designated in the early model, 400 gallons a minute. And we were pretty happy about that. This blue line here is a simulation of Ward's Pond. This is Ward's Brook between Ward's Pond and Level Pond, that interval. So we know it's gaining. Ward's Pond is a very different setting hydrogeologically because it's hard to explain, but this is kind of the ultimate source. This stream between Ward's Pond and Level Pond is what we call the groundwater sink. Most of the water in the area is flowing to that area. So it's hard to, the model's more forgiving in that area because the water has to go somewhere. I put it all in the model for rain, it has to go somewhere, and it all ends up in this reach. So I know volumetrically this is a pretty good estimate. Down here in Ward's Pond, is a more complicated relationship between aquifer water levels, which are a function of the precipitation and the pumping, and actual flow into and out of the pond. So the simulation here, the ups and downs, those are probably very accurate in terms of their relative values one season to the next. But the overall quantity of this value from the pond is very hard to calibrate without some kind of gauge. And I don't know if any of you were around back when the model was done originally. There was a gauge leaving Ward's Pond for a year or so, a year and a half. And that gave us data for pond level versus actual amount of water leaving the pond. That gauge is no longer there. It was destroyed a long time ago. So we were working kind of less than quantitatively on this value. We knew we were correct to the ups and downs, but that could be shifted up a little bit, down a little bit. It's relative value, point to point to point, I think is correct. And you'll see out here at the very end, during those very dry seasons, flow into and out of Ward's Pond right around zero. It looks like it's balancing out. So in a really dry 2 years in a row, that's going to be a stress condition according to the model. One thing we'd really love to do is come out in dry conditions like this and see if it's really happening. See if this really should be 100 gallons a minute. That would allow us to calibrate what they call the conductance nodes in the model so that we could get a better handle on actual relationships of that level of pond with levels in the aquifer. And it's just something without that hard data, it's hard to do. We have enough information where it's a good estimate, but it's not the best estimate that could be had. So anyway, this simulation seemed to work pretty well. We're happy with